Welcome back to Ox Tools. I'm Tom. So, a couple people have asked me about the big etching press Handwheel, and I just recently got started back on that. I was doing a bunch of grinding, and I got tired of the grinding, so I took a break and worked on a bunch of other stuff. But while I was kind of off, not working on it, I thought of a better way to do the radius on the spokes. So this is one of the spokes here. This is one that I ground here, and this took I don't know, over an hour, around an hour to do this radius, plus some a bunch of hand work. So just figure on about an hour a piece of hard labor, I guess you'd call it. So you can machine radii like this, but kind of hard to do on a big S curve like that, right? So what I got to thinking about was the wood guys got some interesting tools, because a lot of their stuff is just handheld, right? And that's one of the fundamental differences between metalwork and woodwork, right? Is woodwork, they hold on to the stuff with their hands a lot, and in metalwork we're clamping things down, and then the machine does the work, right? So to me, that's one of the things that really separate these two. And I mentioned it before, is we've got plenty to, metalworkers have plenty to learn from woodworkers. And let's see, do I have one handy here? Well, I'll show you the setup here in a minute. Anyway, so I'm going to show you a setup, and I would call it unorthodox and a little bit hairball, if you like, but it works, okay? And it's going to save you a bunch of work, okay? And the work that it is simpler for me and less back breaking. So we're going to show the setup, and then we'll show a little bit of of how the thing goes. So let me move the camera around, and we'll get cracking. Okay, so here's the setup here. I got one of these spokes up in the mill here, and it's all clamped down, and I got a little bit of clearance underneath. And what we have here is we have a woodworking carbide, brazed carbide, 1/2-inch shank, brazed carbide roundover bit. Okay. Now the thing, now metalworkers have the same thing. Okay. So here's a metalworking version of that. But the major difference here is this doesn't have any kind of follower bearing, okay? So these are for following templates or actually tracking along the edge of the part, and that's the key here. So this one won't track along the edge of the part, so what it'll do is it'll gouge it, okay? And which is what we don't want. And now with the follower bearing, what I've been doing here is I'm using the follower bearing as a visual feedback to adjust the two axes. So as this rubs along the part, when it's in contact with the part, the bearing's not turning, and I can see that. And then when I'm away from the part, the bearing turns. So I have some directly linked feedback, excuse me, to move the handles, okay? Now, I've tried it a couple times, and it works pretty good. Keep in mind, this is not going to leave a perfect finish, okay? What I'm trying to do is just get most of that material out of my way so that I can go back and do a very light amount of grinding and sanding and handwork. So what I'm just trying to do is just remove that material in a similar radius and kind of get it out of my way. And I'm going to zoom in here, and you guys can see this thing here running. So anyway, that's kind of the main difference there. Woodworker, metalworker, and that's a bigger one there too. These are relatively cheap. I have a router that'll take 1/2-inch shank, so that's a pretty sturdy tool. It's got a little more positive rake than what we would see for for metal work, but it's pretty well supported, and it's supported with steel behind it, so that's what we care about. So this is like a brazed carbide inserted tool, and like I said, it's a little more positive than we'd like to see for metal, but it does work. They work wonderfully on aluminum and soft materials. So anyway, let's go ahead and let's try that, and you guys can see that in action. Okay, so keep your eye on the bearing there. Okay, you see it stopped. So now what I'm going to do is I'm just going to engage the feed, and then I'm going to work the y-axis here. So anyway, you get the idea, right? Now, let me check something here. Yeah, okay, we can go significantly deeper on this one here. What I don't want is I don't want a hard line on any of these edges here. I'm going to set it a little bit lower. So if I don't like what I did, I can just kind of go back over it if I want. Yeah. All right, let's do that one. I'll tell you, this is a lot easier on your nerves than grinding. Okay, Now, you know, as you can see, it's not a perfect finish, but it's a lot of material that's been removed, okay? And it's going to make my life a lot easier when I go back and hit that with a sander. Yeah, I could probably go back over that a little bit. And the cutter's hanging in there. This is the third one of these it's done. So anyway, so just for kind of shits and grins, I got a file out here, and I wanted to just see, you know, how big these bumps are and what it would take to get those off. So they look. So what I'm seeing here is there's not a lot there between ridges. So dimensionally they're small. They look gruesome when you first look at them, but I guess what I'm seeing is dimensionally, you know, a little draw finally takes them off, and I'll probably end up with more uniform results too. Anyway, that was just kind of a, you know, what the heck check there. Okay, so we whacked our way through all these guys here. It really cut down on the grinding work. I'm still going to do a little sanding and hand work on these. This is the one I did first, and then these are all done with this weird router bit technique that I was showing you guys. So just to eliminate some of the questions, this is a 1/2-inch shank Cascade Tools, and it says made in Taiwan. I looked these guys up. They don't list any router bits. I think I got these many years ago from the predecessor of Grizzly, although I'm not positive. It says SY something on the shank of these. Anyway, the cutting edge held up fine through all that steel. Still feels good. I didn't chip it or nick it. The bearing did die on the last edge of the last one. I was well, not pleased that it failed, but you know, if it was going to fail, that was a good one to fail on. And I could have, you know, flogged another bearing off one of my other ones, because I think the bearing is just a common one. Anyway, the bearing's kind of, yeah, it's kind of jacked up. But the cutter's still good. I'd keep going with that. Anyway, that technique worked, and I actually got better at it because you could feel the tool pressure with it through the handle, and actually kind of compensate for it. And so it got easier. I was able to crank the feed rate up and get going pretty good there. So anyway, we'll do a little hand work on these, and then we're going to do some weld assembly. So I'm getting excited. Okay, so we got the Troyke Rotary table kind of cleaned up a little bit, and the next thing we have to do for this, we're going to use this on the hand wheel after it's welded up to round over the outer rim, the 48-inch diameter rim. So I need a hand wheel here. This was missing the hand wheel when I got it. So we're going to fabricate and machine and fabricate a new hand wheel for this. So I got the saw going over there, and we'll go take a look at what's cutting over the saw. So we got the Johnson saw going on this big heavy wall tube here. We're slicing off a section for the hand wheel rim for the rotary table. So I believe this is 4140. This is just what I had around in something that had a hole in it, and that was the right or close to the right diameter. All right, so here's the hand wheel assembly. This is what we're building out of these parts here. The tube, heavy wall tube, and the hub, and the flat bar. We're going to assemble it into a hand wheel for the Troyke rotary table. So let's go over to the lathe and let's get cracking. Okay, so we're over on the lathe. We gotta, I think we're just gonna grab this puppy on the ID here like that and open the chuck into it. We got enough clearance here to, we can face that off. This is the socket side, so we're gonna face that off and get it cleaned up. Make sure my double boost light's pointing right. Okay. Where are we at? Well, the OD and the ID of this thing are pretty unconcentric. Yeah. Well, that doesn't really matter for the facing. What do I want to do there? I think I'm going to go ahead and face that anyway. Even with it running out like that, I'll get two parallel sides, and then we'll grab it by the OD. I got to take some out of the ID, and we'll get that concentric, and then the last thing we'll do is probably the OD. So. That's a little fast. Let's try that. That's better. That socket's pretty crooked, so take a little bit to clear that off. Clear some of these chips out of here before they give me a hard time. Look at the color of those. It's a real interesting color. This kind of grayish blue. It's partly because the chips are kind of thin and they're hot. I don't even want to get near them there. Out of my way there. The chips are getting longer now, so if you don't clear them out of there, then they'll clear themselves out of there in a way that you don't want them to. So, all right. that swoosh, that's the, that means the tool's it's cutting good. It's hard material, but it's cutting good. Oh yeah, nice finish. Alright. Let's see, I think enough. Sure, why not? Still warm. Let me get a soft hammer here. A whacker. Okay, so now I'll get a boring bar going, and we're going to bore some of that ID out here. Looks like it's okay. So what I'm going to do is go in there and oops, bump my camera with my head. That's what I'm going to do. I'm going to calibrate that bottom surface as 0 there, so I know when I'm getting close to it. Okay, and what do we got for speed? Sure, change the direction. Just touching the, take another pass here. Get a look at it. Oh yeah. Finish. Not cutting all the way around, but it will. Okay, so I'll take a couple more passes, get it rounded up. Let's see, can you guys see what's going on? Yeah. Let's slow that down just a whisker. That's 395 RPM. We're gonna kick it down to 200. Let's see how that behaves. Seems a little slow. That's kind of slow. I don't like that. I don't like that. Let's try that. That's 285, I think. 285. Oh, delete. Alright. That's better. I switched boring bars and changed some stuff around. Remember, this is chromoly here, 4140. So let's see, it's stacking up in there. Cool. Okay, so we're what, 285 RPM. I'm not sure what the feed rate is, but we're taking about 150 thousandths per pass here. And it's behaving itself pretty well. Alright, so we're going to bump this in now. So which way are we going here? Okay, that's big. That's a high. Crank this in a little more so I can see the needle better from my crummy angle here. Alright, so it's close. I'm gonna snug it a little more. Remember to go the right way because I'm clamping on the ID here. And the reason I'm indicating this is because I've spaced it off at the back of the chuck because I don't want to cut my chuck jaws when I flip it around. Actually, you know, I should have just shimmed it, huh? Oh well, it's not that big of a deal. I just want it close. It's pretty close. Alright, I'm going to call that good. It's just a hand wheel, right? It's not some die part or something that's got to be dead nuts. Okay. Alright, so I'm going to turn the OD, then put some chamfers on it, then finish this puppy up. Okay, big fat chamfer. That's 60 thousandths chamfer, about 1.5 millimeters. Okay, get rid of these death chips here. Alright, so I'll flip it around and I'll chamfer that, and then that ring is done. Let's see, there's a tapped hole that I got to put in it, but it's pretty easy. So. Alright, so what do we got here again? Let me just double check it. 757.